Does anybody have anything for the office? All right, not today. Thank you. All right, we're on page 193. So this is our last section. We have about 3 pages of front, back, and then another front. And that's it for this section. Then we're going to have your free response day. So I have it up on the board. That will most likely be Wednesday. And then we're going to get your quiz in on Thursday before break. All right, so this section's not too long. It shouldn't take us too long to get through it. All right, so let's just go ahead and get started. The graph of a cubic function of the form, and it gives that there, is pictured to the right. Use the graph to answer the questions that follow. So based on the graph, what can we conclude about the values of A and D? Give reasons for your answers. So they give us that generic form there, and they give us a graph on the right. So what can we tell about this A and this D from looking at the graph? What do we know about them?
We know that D equals 1 because the y-intercept of the graph.
Alright, so we know that D is equal to 1, and that's because D is the constant term or the y-intercept. That is true. We know that D has to be equal to 1. Very good. What do we know about A? You might be headed in the right direction. It's going to tell us something possibly about it.
A is negative because the right side of the graph is going down.
Yeah, if we look, this graph is going down, so it's in a negative direction. So our leading coefficient has to be less than 0 or has to be negative. So A is less than 0. Now, it is less than 0. We have that negative direction, but we have the left side going up and the right side going down, and that's because of what? Yeah, odd degree of 3, yeah. So A is less than 0, and because degree is odd, and graph rises to the left and falls to the right. So the graph rises to the left, falls to the right. Alright, so if we go on to letter B, based on the graph, what can you conclude about the roots of g of x? Explain your reasoning. Go ahead, Marie.
2 would be imaginary.
Alright, how do you know that?
Because there's a degree of 3, but only 1 is imaginary.
Alright, so we know that the problem is a degree of 3, but if we look at the graph, we only actually see 1. That one root, is it positive or negative? Alright, so g of x has 3 roots. 1 must be positive, and 2 must be imaginary. So g of x has 3 roots. 1 must be positive, and 2 must be imaginary. For letter C now, it says, based on the graph, what is the maximum number of sign changes that the equation of g of x could possibly have? And give a reason for your answer. So this would be back probably to the beginning of last week, maybe the end of the week before you were dealing with this with Mrs. Bauer. So what is the maximum number of sign changes that the equation of g of x could possibly have? I'll give you a minute to look back if you're looking. Good. Okay, so 3 is the maximum. How do you know that?
It can't go past the highest degree.
Okay, so the highest degree is 3, so we can't have more than 3 sign changes. So let's state it like this. How many real roots do we know that we have with this problem? 1. So g of x has 1 positive root. The number of sign changes in g of x is the maximum number of positive roots that g of x could have. So we're saying the number of sign changes in g of x is the max number of positive roots that g of x could have. So g of x could have how many sign changes? It's equal to the maximum number of possible roots. So we could have how many sign changes? The 3 sign changes, like you said at the beginning, yes. So g of x could have 3 sign changes. Now we know since we have the graph, we only have 1 positive root. But just like we said, the number of sign changes is the maximum number of positive roots that we could have. Any questions on that part? It's not saying the sign changes on how many positive roots we do have, it's on the possible roots we could have. Everybody okay to move on to D? Alright, if the coefficient of the linear term in the equation is -3 and g of -1 is equal to 8, find the equation of g of x. So we're trying to figure out what all of these coefficients are so we can actually write out this function. So the first one, let's just write out what it is. G of x equals ax cubed plus bx squared minus 3x plus 1. So they told us we have a -3 in front of the linear term. Well, x is linear, so the -3 goes in front of the linear term. And we already know from up above, we found out that the d was 1. That was from the picture on the graph, that was the y-intercept. Now what did they tell us g of x is, or what are we going to plug in for g of x, sorry, in this example? Marie? Yeah, we're going to plug in -1 for all of our x's, and our answer should be what?
8.
Okay, so we're going to have 8 equals, we don't know what the coefficients are yet. So plug in your -1s. Yeah. All right, we're going to talk about that. We have the -1 in the cube, so now when we simplify this, -1 cubed is what? -1, so we're just left with that -a there. So our leading coefficient is negative. -1 squared. It's just 1, so we're left with plus b. -3 times -1, so we're left with plus 3, and then plus 1. Now we need to get these numbers and move them all to the left side. So if you subtract a 3 and then subtract a 1, you're left with 4 over here, and -a plus b. So from what we've done so far, can we really tell what A or B is? No, and can we really go any further with this right now? No, we're kind of stuck right here. So if you look right here, they gave us g of -1 equals 8. They told us what that answer is. If we go back up to our graph, can we actually find out what another answer is? Is there another answer we can easily get from the graph? Anybody have one? You think you have one, Marie?
G of x equals 1.
You might be headed in the right direction.
G of 1 equals -2.
That's what I'm thinking of, yes. So we need to do g of 1 equals -2. So if you look at your graph, g of 1, the answer is -2 right there. Okay, so we're going to use that on the bottom. Now we're going to do the same thing we did over here, but we're plugging in 1 this time, and our answer is -2. So plug in just like we did over here, but -2 is your answer, and you're plugging in 1 instead of -1. So we're left with -2. A plus B minus 3 plus 1. When you simplify and you move your numbers to the left side, what are you left with on the left side? Yeah, we get 0 equals A plus B. Can we really go any further with that side now? No, we can't simplify that side any further, but using the 2, can we find an answer now? How can we use both of our answers to help solve?
I can't remember what it's called, but we can overlap them and combine like terms because the A and the negative cancel out.
Okay.
Use like elimination.
Yeah, elimination, exactly. So we have the -A plus B equals 4, and then A plus B equals 0. If we add them together, it's going to eliminate the A's. We'll get 2B equals 4. So B is equal to 2. Now, how do we find out what A is?
You plug it back into the original. Like you plug your answer for B back into the original, like one of the original equations that you had.
Yeah, you can plug it in here. You can plug it in here. You're going to be able to find what A is. So if you plug your 2 in for B, what do you get for an answer for A? This one over here seems easier to plug it in. A has to be what?
A would equal 2.
Close. If I plug it in here, I have A plus 2 equals 0.
Oh, sorry, negative 2.
Yeah, negative 2. So we've done all this work so far. Have we actually answered the question yet? No, what are they asking for? You go back, read the question. What do they actually want? Yeah, have we found all the pieces of the equation? Do we know what A is? Do we know what B is? Do we know what C is? And we already found D up above. So we do have all the pieces. Now we just have to list it. So g of x equals negative 2x cubed plus 2x squared minus 3x plus 1. And you have found the equation of g of x. Any questions? All right. On to the back. So we're going to review some stuff you have done already. So a little bit of a refresher. You may have to look back some. Consider the quartic function. So they have it listed there. To answer the following questions. Use Descartes' rule of signs to create a chart of possible combinations of the types of roots that f of x will have. So maybe read that again if you don't remember how to do that. Maybe look back. I'm going to start writing out what the chart will be. And maybe as I write the chart, you'll start to remember what we're going to do. You remember seeing this chart or doing problems like this? Alright, so how do we use Descartes' rule of signs to actually fill in this table? Or who can help me fill in the table? And I guess a good thing to figure out before we start that is how many roots should we have? We should have, let's say total roots should be 4. So just make a note of that somewhere, that way you're aware of it. You should have 4 roots. Now, how do we actually use Descartes' rule now to fill this table in?
With a positive, we can count the number of sign changes in the original equation.
Yeah, so we go to the original one and we count the number of sign changes. Well, how many sign changes do you see? 2. We have a sign change from here to here. It goes from negative to positive. Then it goes from positive to negative, and this one stays the same. So we have 2 sign changes. So where am I going to put a 2 in my chart? Does that go for positive, negative, zeros, or imaginary? Goes for positive. Alright. Now how do I find the negatives? How many possible?
We would switch any of the odd degrees to the opposite sign.
Okay, that's true. Another way to think of it is what we're actually doing. So you're correct, you would get the right answer, but plug in negative x everywhere you see x. So we're left with this. I'm going to run out of room here. So when you actually calculate the negative x in there, you're left with f of negative x is equal to negative x to the fourth plus 3x squared plus 2x minus 2. Negative x to the fourth plus 3x squared plus 2x minus 2. So how many sign changes do we have? Go from negative to positive, positive to positive, and then positive to negative. All right? We have 2 sign changes, so we could have 2 negatives. That would leave us with 0 and 0. Do we know why these two have to be 0 for this scenario now? Yeah, we have to equal 4 in each row. So we could have 2 positive and 2 negative, so we don't have any left for these. Now, I'm going to go over here on the side actually and list out what we could have. We could have 2 positive roots. We said that at the beginning because of the sign changes. But could we have a different amount? We could have 2 or what? 0. And how did you find 0? Or how do you know it's 0?
Because if you, to test out, you subtract 2, if it doesn't equal a negative.
Yeah, keep subtracting 2 until you would reach a negative or 0. So we could have 2 or 0. And for the negative, we could have 2 or 0. Okay. The zeros. Could we have any 0? What do we have to be able to do? We have to be able to factor out a what? An x. Can we take an x out of everything? No. So there has to be 0. So we're going to fill in more of this table here. So we said we could have 2 positive, and we could have 2 or 0 negatives. We said we're not going to have any of the 0. So we could have how many imaginaries here? Could have 2. But we also said that we could have 0 positives. But we could have 2 negatives. We're just using the scenarios from the left over here that we created. No zeros. That would leave us with how many imaginary? 2. And lastly, they said we could have 0 positives. We could have 0 negatives. We don't have the 0. So how many imaginary would that leave us with then? 4. So you could list over here the imaginary could be 4, 2, or 0. And that kind of makes sense because imaginary always has to appear in what? Pairs. So we're either going to have 0, 2, or 4 imaginary. So this first step is really just listing out the possibilities for this function. Are we okay with the possibilities? Alright, next step then. So, letter B. Sketch a graph of f of x on the axes pictured to the right. Then determine which combination of types of roots from your table in part A is correct. Give a reason for your answer. So go ahead, get a calculator or share one with your partner. Put this function into your y equals button on your calculator, and let's go ahead and graph it. once you get the graph, we're going to go ahead and kind of sketch it. So it looks like it's crossing close to -2, but just inside. It's also crossing, looks like close to -3/4. Looks like it's touching the y-axis, really close to -2, or maybe right on -2. And then from your picture on your graph, we just really need to connect the dots. So we're going to come up. And where does it look like the height of this function stops about? Oh, around 3, yeah. So we're going to go up to around 3, come back down. And it doesn't have to be perfect. We're not artists, but it needs to look similar. All right, so do we all have the graph drawn at this point? We have the graph drawn? All right. So from the graph now, can we determine which one of our scenarios from part A is correct? The third one. So we have 0 plus. We have 2 negatives. There was 0 for the zeros. And 2 imaginary. How did we know there was 2 negatives?
Because it passes the negative side of that space.
Yeah, on the x-axis here, it crosses both times on the negative side. It does not cross on the positive side. It never crosses over here, so we have 0 positive roots. We have 2 negative roots. Well, if we only have 2 roots and we need a total of 4, we must have 2 imaginary roots. So it wants us to explain or give a reason. So it crosses the x-axis on the negative side. So the other 2 roots must be imaginary. So it crosses the x-axis on the negative side, so the other 2 roots must be imaginary. Alright, so we're really going to be using these graphing calculators now. So you really need to have one in front of you or be looking at one with a partner. On part C, do we know how to, using the calculator, find the relative mins and maxes? Have you used the calculators for that? Alright, so let's go ahead and find the relative mins and maxes then. We need to find points. So, if you forget how, is there anybody that's not sure or needs a reminder? After you have it graphed, you go to second calculate. I'm going to find the min first, so I go to minimum. And you need to hit the left bound, then the right bound, and hit enter, and you will get a value. So, what is your value of your relative min? Who can tell me what their value is of the relative min?
And then make this 2.365.
0.366 is the x value, and then negative 2.348. That is your relative min. So that would be at this point right here. It's not quite on the y-axis, it's just to the right side. And we only have one of those. How many relative maxes should we have? How many relative maxes should we have? Yeah, we should have two. We should have a relative max here and there. So go ahead and find your two relative maxes. When you have one, let me know what you get. We should have two. I see some people writing, that's a good thing, but somebody let me know what you get for a max, please.
The max which I found is negative 1.37, comma 2.85, and 1 and negative 2.
Yeah, very good, thank you. So after using your calculator, the two relative maxes you would get are negative 1.37, 2.85, and 1 comma negative 2. Those are the two relative maxes. Now that's not all the question asks for. It asks for the relative mins and maxes, but it also wants the intervals where it's increasing or decreasing. So increasing intervals and decreasing intervals. So when is this graph or this function increasing? If we're starting at the left, where are we starting at? This arrow is technically starting where? Coming from the left. So we know we're increasing from negative infinity. And where do we stop increasing as we're coming up this direction? What is our x value when we stop increasing? Yeah, it is the negative 1.37 because that's where we stop at our relative max. At our relative max, we stop going up. So we know what that point is. So from negative infinity to negative 1.37, we're increasing. Then we're going to put the union here because we're going to have another section where we're actually increasing. And where does that begin? Where are we increasing the next time? What are the x values for increasing? It'd be this little section right here.
Would it be 0 to 1?
You're really close. It's going to end at 1 from our relative max here, but where does our relative min begin at?
0.366.
Yes, 0.366. So these are our intervals for increasing. That second one is 0.366, comma 1. And lastly, we need to know the intervals for decreasing. So where is our graph or function going down? Again, use the coordinates from our relative maxes and mins to help you figure this out. So where does the first one start decreasing at? Negative 1.37. And it goes down until you get to what value? 0.366, good. And then we're going to have another interval. It starts at, getting good at this now, 1. And goes to infinity. Exactly. So we found these out just from telling where the graph was either going up or going down, increasing or decreasing, but we actually used the values of our relative mins and maxes to help us figure out what value we started and we would stop increasing or decreasing. We're okay with that? Alright, last question then. Find the coordinates of the points of inflection for the graph of f of x. Then state the intervals where the graph of f of x is concave up and concave down. So they want us to find these points of inflection, but what is an inflection point? Can somebody describe that? What is the inflection point?
Where it changes from being concave up to concave down.
Exactly, where it's changing from being concave up to concave down or concave down to concave up. Yes, the concavity is changing. So, we need to find in between where it's changing. So somewhere between here there should be an inflection point, and there should also be an inflection point between there. So how are we actually going to find these? We should have 2 inflection points. Do we remember? Yes, that is true. We're getting closer. So how do we find that point between them? We know we have a max here and a min here. So that would be, it's negative 1.366, comma 2.85 and 0.366, comma negative 2.35. So those are the points from up above. So we know that between this point and this point, she just told us there should be an inflection point there. But how do we find that point between those 2 points? These are the 2 points from this problem right before. But we need to find the inflection point.
Find the middle value between the 2 x's and 2 y's.
Find the midpoint. The midpoint of these 2 numbers. So how do we actually find the midpoint? We're right there. We're getting really close. Yep, let's go ahead, add your x1s together, divide those by 2, get your x value. Then take your y values, add them together, divide by 2, and you'll get the midpoint of your y values. So let's figure out what that point is. This will give you one of your inflection points. Negative 0.5 and 0.25. So that is one of your inflection points. But we should have one more inflection point. We need this one from over here. So we need to find the midpoint of our other min and max. So 0.366 negative 2.35, and the relative max of that one was 1, negative 2. So we can find our other inflection point. So add your x values together, divide by 2. Add your y values together, divide by 2. And this one doesn't come out as nice as the first one, but what do we get as an answer for this one? Yeah, 0.683 and then negative 2.174. So, negative 2.174. Now we're almost done. They ask us for one more thing. When is this graph concave up? And use some of the points we just found. So we're talking about the x values, we need those, but when is this graph concave up, sorry. When is it concave up? Let's do that first. From where to where? We got these last two questions here, concave up and concave down, then we'll be done for the day. So I need one of my x values here and an x value here. So looking at the graph, where is this graph concave up? Yes. Good. From negative 0.5 to that 0.683, so right here, that's concave up. Very good. And we need, lastly, the concave down. It's the last interval we need. Yep, go ahead. Very good. Yes. Negative infinity to negative 0.5, union 0.683 to infinity. Awesome. All right, very good. I'll leave that up on there for a few minutes, but that is where we're stopping today.